All right, today we're diving into something pretty wild. It's a radical idea that says pretty much everything we think we know about the cosmos is just plain wrong. We're going to take a deep scientific look at the electric universe hypothesis. This one quote from Wallace Thornhill, one of the main proponents of this whole thing, really says it all. He's saying stars aren't giant balls of gas, they're light bulbs. It's a bold claim that basically kicks gravity off its throne and says the universe is really run by a force we all know very well, electricity. I mean, it's a pretty compelling question, isn't it? What if it's that simple? This is the what if that kicks off our whole investigation today. We're going to look at the claims, we're going to put them up against the hard evidence, and we're just going to see where this all leads. Okay, so let's get right into it. What exactly is the electric universe hypothesis? Well, at its core, it's not just a new idea. It's a proposal to completely throw out standard cosmology. We're talking no Big Bang, no dark matter, and the idea that gravity is actually a pretty weak, almost insignificant force on the cosmic scale. Now, this is where things get really interesting because we have to make a super important distinction. You see, there's a legitimate, though not mainstream, field of science called plasma cosmology, pioneered by a Nobel Prize winner. The electric universe borrows some ideas from it, but then it makes these much more radical claims, like stars being powered externally by electricity. And that's a key difference we can actually put to the test. So let's do just that. We're going to put the absolute centerpiece of the electric universe hypothesis on trial, the electric sun model. The idea here is that our sun, well, it's not at all what we've been taught. And here's the core claim, right here. Forget about a self-contained nuclear reactor in the sky. The idea is that the sun is basically a giant anode, the positive terminal, in a massive cosmic circuit. It's a huge light bulb being powered by the galaxy itself. This is a complete and total rewrite of how stars work. So how in the world do you test an idea like that? Well, it's actually pretty straightforward. If the sun is a nuclear furnace, it has to be spitting out these tiny little particles called neutrinos. They're like the smoke from the nuclear fire. If the sun is electric, there shouldn't be any. So the question is simple. Do we see them? And here's our first answer. The prediction is for 0 neutrinos. The reality? We detect a massive, non-stop flood of them coming from the sun every single second. In fact, scientists won a Nobel Prize for figuring out exactly how these neutrinos behave, which was a massive confirmation of the standard solar model. So on this test, the electric sun model is completely falsified. Okay, so the neutrinos don't work. Let's try another test. What about the light from the sun itself? You see, the light an object gives off, its spectrum, is like a fingerprint. It tells you exactly what it's made of and how it's making its energy. And this just lays it out so clearly. An electrical discharge, like a fluorescent light in your office, only gives off light at very specific colors. You get these sharp lines. But what do we see from the sun? A smooth, continuous rainbow, the classic signature of a hot, dense object. The observation is the literal opposite of the prediction, another clear falsification. But the theory doesn't just stop with the sun. Oh no. The proponents take these same electrical ideas and try to explain all sorts of things, from what comets are to how the very canyons on other planets were formed. So according to this model, comets aren't dirty snowballs that are just, melting in the sun's heat. No, the idea is that they're charged rocks that get into a massive electrical battle with the sun's environment. And the coma and tail we see, that's the result of this cosmic electrical machining. But here's the thing. We went there. We sent the Rosetta spacecraft to go and sniff a comet up close, and the data it sent back was just devastating for this model. For the electric model to create the amount of water we saw, it needed a certain amount of fuel from the solar wind. What Rosetta found was a shortfall of 7 orders of magnitude. That's a factor of 10 million. The theory isn't just a little bit wrong, it's wrong by a mind-boggling amount. The math just completely falls apart. Now, this might be one of the most dramatic claims of all. The idea is that massive canyons, like Valles Marineris on Mars, which dwarfs the Grand Canyon, weren't formed by slow processes like erosion. Nope. They were zapped into existence in an instant by a colossal interplanetary lightning strike. But when actual geologists look at the rock, they see a totally different story. Valles Marineris has all the classic fingerprints of a tectonic rift, a giant crack in the crust of the planet. And then, over millions and millions of years, it got wider thanks to landslides and erosion. There's literally zero geological evidence of some kind of high-energy electrical blast. So you have to ask, right? If the evidence just isn't there, if claim after claim falls apart when you look at the data, then where did these ideas even come from? And how do the proponents keep arguing for them? Well, the family tree of this idea doesn't really trace back to modern physics. It starts with a really controversial book from 1950 called Worlds in Collision, which basically said ancient myths were literal accounts of planets flying around the solar system. Those ideas were then picked up and are now promoted almost entirely online, completely outside of the normal scientific process. And this quote, this is just so revealing. Peer review is the absolute bedrock of science. It's how we check each other's work. But here you have an admission that they are actively bypassing it, using the label interdisciplinary as a way to say, oh, no one else is qualified to judge our work. And that leads us to this really common rhetorical tactic. It's called the Galileo gambit. It's the argument that says, hey, they laughed at Galileo, and he was right. They're laughing at me, so I must be right too. It's a clever way to reframe legitimate scientific criticism not as a failure of evidence, but as proof of a conspiracy against the truth. All right, let's pull all these threads together now. We've looked at the claims, we've looked at the evidence, we've looked at the methods. It's time to put it all together and give a final verdict on where the electric universe hypothesis really stands. And you know, the crucial thing to see here is that this isn't about one little mistake. The hypothesis fails on every single level that matters for a scientific theory. There's no real mathematical model that can make predictions. The predictions it does make have been proven wrong by direct observation, and it fundamentally rejects the very process that science uses to find the truth. And this, right here, shows you the fundamental difference in approach. Science is a method for testing ideas against reality and being willing to throw out the ones that don't match up. The method we see here seems to be about defending a story no matter what. It relies on saying there's a conspiracy, using logical fallacies, and appealing to our desire for a simpler, more dramatic story. And that really leaves us with this final, really important question. I mean, history's full of scientific rebels who turned out to be right. But the difference is this. True scientific rebels bring new evidence. They bring better models that make more accurate predictions. They don't just reject the mountains of evidence we already have and ask you to believe in a story instead.